Keep me out of range.
Field trip
no.
time, guys.
No, keep me out of range.
I see you.
Can you hide me? I don't want to be in the camera. I don't want to be in the camera.
Say hi.
Everyone cover me. I don't want to be in the camera.
It's field trip.
How many views I got? 1,000?
Sure. I mean, it's a 0, but yeah, let's go with 1,000. Yeah, exactly.
Look, that
Add a
looks
1
nice,
to the 0 and then multiply it by 1,000. Whoa.
Benjamin, stop recording.
Oh, it doesn't record outside.
There's no Wi-Fi?
Still, you're alive, right?
Oh, there we go.
Okay.
All right, we're back.
So what we're gonna do is you're gonna bend down and face that angle. Bend down, facing the angle. You're an idiot. My God, you're the smartest people that doesn't know what the angle is. Okay. Okay, so bend down. Do you know how to bend down?
Yes, you want to kneel?
Okay. Bend down on the other side. Do you know how to bend down? There we go. Wow. Okay, I want you to whisper something to the other. Whisper to the wall. Do you hear anything?
What?
I think he has his AirPods on.
Listen. Take out your earpod.
Yes.
We're trying to hear about the Olympics.
Okay, over there. Go toward the wall.
Are you ready for the focus? Who do you think I am? Jerry from fucking Jerry.
Listen, hey, one side, listen.
Are they?
Okay, talk.
Say something. I don't want to.
Can you guys hear anything?
Yeah.
Yeah, I can hear them. Yeah.
No, just whisper. You can hear it. You can hear?
I can hear a song, but I don't know what it is.
Okay, you're too fat. Go away. Just one person over there. Okay, now get off. Here. Okay, so one person, just here. One person. Okay. So now you whisper to the wall.
Seems like he...
Can you hear anything?
Tyler.
You are deaf.
Tyler, no.
Okay. Okay, you are deaf. Try something else. Try somebody else. Go try over there.
You should try
Okay,
it.
go.
I think we're done.
Me?
Okay, Naomi, go.
Wait. So do I go or?
Josephine's a weirdo. She talks
Hurry up.
Josephine's a weirdo. She talks to the wall.
Okay, whisper to the other side. Yeah.
She couldn't hear you when you said that.
See? She could hear it. Like,
Oh, we're learning about the focus.
yes.
Do you hear it?
Yeah, she could hear it.
So you can whisper from one side, the other side can hear, right?
Say a word.
Say something. Say a secret message to them. Who the hell are you?
You're talking.
Huh? Why are you here? Okay, so anybody want to try it? Okay, no, you guys cannot hear. You're deaf.
What do you
I wanna
mean
try it.
Carlos, go.
If you put me to focus,
Carlos,
I
go.
know what we're doing. No.
No. You can try some other time. So get off.
In between class. Come over here. I have to tell you my...
Carlos, can you hear?
Okay, what the fuck? It actually works.
Yeah.
What? That was bullshit. I'm not gonna lie. That was bullshit.
That's weird.
Wait, no, go back.
He's like, can I try again?
You're not even my student.
Say something.
But it works.
Do it again. What the fuck? Fucking possession. Oh, no.
Alright, let's go. You guys can try something. Oh, you want to try it?
Take the iPad.
Or Jasmine, you go here.
I didn't see anything.
Yeah, absolutely.
Literal, que baila, parce.
I know, I'm just kidding.
No sé, me pareció raro. Yo creía que era pura mierda, pero... pero sí, sí, cierto.
Why am I holding the camera? There's not even anything to record at this point.
Try really quick, really quick. Bria!
That's Jasmine!
I can hear Benji. I used to whisper you. I can't hear Bria.
How do I stop the stream? Tell me, how do I stop the stream? What am I recording?
Let's go. Come on, go to the car.
Benji!
No, you don't
Record the rest of it.
Alright,
The point is not to scream.
this is the conclusion of the field trip.
Why are the smart people in the back?
Because they're dumb. They might be book smart.
Hurry up!
They're dumb.
And you call yourself a soccer player.
We're back.
Benjamin, no more recording.
No!
Wow.
No.
Hi, Nick.
Okay, go.
Benjamin,
Put it on
take
the
him, Mr.
tripod.
USC.
Huh?
Take him, Mr. USC.
Put it on the tripod. We're gonna record. Listen. Hurry up.
Mister, that video gonna be 2 hours.
That's okay. That was a side field trip.
There we go.
It's more amount of time that you can have to fall asleep.
Okay, so make sure on that side so I can see the screen. No, no, no.
Where
There, a little
the
bit angled, yeah, so you can see the whole board. And don't block all the people.
There we go.
Okay, so here's an interesting fact. Interesting fact is this, that those of you guys didn't hear it, you guys more welcome to try it later when like a lot of people's not here, or try it with your friends. It's really cool. So it's basically, it was this and like this. And so you whisper to this side of the wall, you can hear it from this side. It's actually a very interesting phenomenon. So we're going to talk about today, but I actually don't understand the mathematics behind this one, but I understand the mathematics for other one. So, like, you see the best expression, I don't know if you record that expression, that guy that's not even in our class, he's like, what the hell, is, you know, he starts cursing, he walk away. So it's interesting because if you whisper from this side, you can hear from the other side. And think about how sounds traveling, which is really interesting. So what we're going to talk about is, here, we're going to talk about a shape called ellipse. Okay. Ellipse has two foci. Anybody want to take off their shoelaces for fun? Shoelace? You have shoelaces?
Benjamin.
You have shoelaces? Want to take it off? No? Nobody want to take it off? So, fine.
That's a lot of work to put it back on.
Yeah.
You have your own. My shoes are laceless.
Oh, yeah, and you gotta stay here the whole time.
Okay.
You should take it off.
You want to take it off for me?
I'll take it off. Bet.
Benjamin dies. He's like, what is that?
Okay. So, a lot of you guys don't know how to draw an ellipse. Do you know how to draw an ellipse?
I don't even know how to draw a circle.
You? How to draw an ellipse?
We know. We
Yeah, how to draw it.
She said, wait, no.
Yeah, how do I draw a perfect ellipse?
Oh no.
Oh no. A line is a problem. Can you draw a line?
Any day now.
Come on, baby.
Oh, you do specific.
Right there you go.
Okay, so what happened is this is the rope, right? I'm gonna tie it. Hopefully I know how to tie it.
Doesn't look like it.
Shut up. You look like a knot.
Yes.
Okay, so this is rope. I need a strong person. Who's strong?
Oh, Benjamin, he does wrestling.
Oh yeah, Benjamin, come on. So what I'm gonna do is I'm gonna draw ellipse. So first of all, we talk about we know how to draw a circle, right, with a tool called what? What's that thing called? A compass. Good. A compass. So you can actually draw a circle this way, right? Like one center. Yeah, you just take it like draw it, and you draw a circle, right? But the problem is, how do I draw ellipse? So it turns out ellipse you need 2 points. So I want you to hold this here and put it against here. Yes, put it against here. And you cannot move, okay? And also another one here. Okay, not all the way, not all the way.
Not
Like,
all the way.
there's some slack, yes. Some slack. And you cannot move this position. You're strong enough? Okay. So what I'm gonna do is I'm gonna take a marker. I'm gonna stretch this as far as I can. Okay, and he cannot move. Let's label those marker first. Right here and right here. Okay, so what happened is I'm gonna take this, I'm gonna stretch as far as I can. You follow me? And I'm gonna do it, I'm gonna draw an ellipse. Okay, now we gotta change position. Alright. Oh, you just moved.
I gotta reposition. There we go.
Is it in the right position?
Yep.
Okay, let go. Okay, so that this 2 point is called a foci. It's called a foci. It's called, 1 point is called focus, but this point is called foci. This 2 points called foci. Okay. Do you guys know your U.S. presidents?
I know like 3 of them.
Donald Trump.
And George Washington.
George Washington. Okay, so do you guys know last name Adam?
Oh yeah, John.
John Adam.
Yeah.
John Quincy Adam, right?
Yeah.
John Quincy Adam was a very smart guy.
Well, yeah.
He was in the Congress, right? And he will specifically set his table in a certain spot on one side of the room, and he will listen to what the House representative was talking on the other side of the room. Secretly, without people knowing. He just don't talk, he just sit there. He listen. Okay. And this was one of those things that is in the Congress, because the Congress is built in certain shapes. And so elliptical idea is actually, this phenomena is actually that a lot of people like don't understand that it's very interesting. Not only that, you can build a pool table like this shape, and you can have a hole on this side, and you have a label on this side. And if you use this label, you hit the ball in any directions, it's gonna bounce off and then go into the other hole. You can hit in this direction, it's gonna bounce off, hit in that hole. If you hit this direction, it's gonna bounce off the other hole. So you can actually build that type of pool table. Okay? Okay, so now
Make sure it goes
back
home.
my shoes.
The kids robbed me.
The kids robbed me. Take my shoes. My retirement file is stolen. So it's an interesting phenomenon like this, but it turns out can be used for a lot of things. So let's first talk about first phenomena. First phenomena is actually medical. Okay. So how many of you guys know that anybody have kidney stones? Raise your hand if you know kidney stones. Macy, who has kidney stone in your family or in your?
My dad.
Your dad? Is it painful?
He had to go to the hospital 4 times.
Okay, so what happened is 20 years ago, I don't know if the technology is still the same way, but 20 years ago, they use an elliptical principle to get rid of kidney stone. So the person that you will build a chamber looks like this, like a three-dimensional chamber looks like this, and this person that with a kidney stone right here. And the other person's right here, that this here is a source. Okay, so you're gonna, what kind of source? It's ultra frequency source, so it's a sound with ultra frequency. So like, you know how like people can break a glass with the pitch of the voice?
Oh yeah.
You have to pitch at a certain resonance. You have to have matching the same resonance as, you have to tap the glass and hear that resonance, and you have to produce the same pitch as that. And you can actually break the glass. Okay, and you can practice it to do that. You can, small by practicing, like crack the glass a little bit, and that's easier to break. But they are a way to train for you to break the glass. If you are in course, you can more welcome to try it. Okay. But what happened is the source that is gonna produce an ultra frequency sound, like only dog can hear it, or I don't know. And that sound is gonna hit. Now remember, when I'm talking to you, the sound is going like a circular motion, so it's radial like a ripple. So behind me can hear me too, right? It's not because I can't see them, but my sound source is right here. So it's gonna hit this part, and it's gonna bounce off to hit here. And this part is bounce off, hit here, bounce off, hit here, bounce off, hit here, bounce off, hit here. So it turns out it's like taking all the sound source, build it into one channel. And just think about if I have one small tube and I talk through, or I yell very loud, or I sneeze very loud, or I ask Conde to sneeze very loud on one side, then he can actually concentrate that sound into one specific line and break your eardrum. Probably can, right?
Bro, he broke my eardrum.
Don't ask Conde to watch this video. So, as if you are doing like this, it turns out it's to magnify all the sound wave at the same time to like almost like 1,000-fold. So, but the sound wave doesn't hurt your skin, right? Well, it doesn't matter how loud is it, your skin's not gonna break a hole. But the kidney stone will. So something that is concrete, is hard, it's gonna break. It's gonna burst to small pieces, and then you can beat it up. Okay, it's called elliptical principle. Also, you know, how the world runs, literally. Okay. This is the sun. And this is Earth. Oh, that Earth doesn't have a ray, sorry. I'm stupid. Earth. And so that kind of proves that there was 4 seasons. Because I hear it's more likely a summertime. You are more closer to the sun. I hear it's probably going to the fall. I hear it's probably like the winter time. And I hear go back to spring, go back to fall. Okay, that's what you have. And also there's other factors as well that I don't know about, but there was another factor. And some people say, so how come that, you know, if this is a 4 season, they should equivalent 3 months. Does that mean this part that Earth is rotating faster here, going faster? That part I don't know. I'm gonna be the first one to claim. But if you are interested, watch 3 Blue and 1 Brown. There's a math video. They have all kind of math video they can explain. They actually talk about the area it's covering from this region and at same time of this region that the area is covering. They actually talk about what's the proportion, or are they the same area or whatever. They actually talk about all that stuff. It's very interesting. Okay, so if you want to get to that, that's a very interesting part of mathematics. Now, a lot of you guys probably don't understand the math behind it, and that's okay, but at least I can connect the real applicable life knowledge to whatever you're learning. That's more important than anything else. I don't care about it. One day later, I don't want you to tell me, says, oh yeah, how's the elliptical how ellipse formula is. I want you to tell me how elliptical principle works. okay? And I want to, in the future, use elliptical principle or use other things I teach to develop the things that you are researching or whatever, and beyond my skill. But that's your responsibility, not mine. Mine just give you the introductory. And hopefully you guys kind of interested about this. Okay, does that make sense? Where's my rug?
Remember the one that you were whooping?
Behind you.
Okay, so a lot of you guys don't appreciate like this part of math. I think I appreciate a lot more because I understand the theory behind it. You know, look at John Adam, look at elliptical principle, look at the season, look at the theater, and all those things are related to mathematics. But a lot of you guys don't know what is it. Oh, math is so useless. But the problem is you use it without knowing. Okay, your iPhone, your apps, your things, your radio signal, all those things has something to do with mathematics. You just don't know about it. That doesn't mean you don't. It's not applicable to life. I always tell people don't have to take precalculus. It's useful and it's not useless in life. Yes, it's true. But it can also be useful in life. Depends on how you look at it. So let's talk about ellipse formula. So it's x squared over a squared plus y squared over b squared. That's equal to 1. That's a center 0, 0. What's the difference between this equation and the circle equation? Yeah, a and b. And there's also another difference on the other side. 1. So if it's equal to 1, it must be an ellipse. Well, most likely it's going to be ellipse, unless this is 4 and 4. But then that's still a circle. So if it's this 1 and this is 2 different number, a does not equal to b, more likely they are a circle. Ellipse. And how do I draw this ellipse? It's very easy. A represents the distance from center to x direction. B represents the same thing to y direction. So therefore, if I have x squared over 4, and plus y squared over 9 is equal to 1. So how do I draw this ellipse? Oh, pretty easy. 1, 2, 1, 2, 1, 2. So I know in x direction I'm going to go 2 units to the right and left. So I'm going to be here, I'm going to be right here. And y direction I'm going to go what? Square root of 9 is what? 3 units, so it's going to be here and here. So then I can draw my ellipse. Now ellipse has a couple things. First I want to express what is a vertice? Vertice is the longer side, so this side is called vertice. And this side is called vertice. So vertice, so at 0, 3 and 0, -3. There's a co-vertice. Co-vertice is the shorter side because co means a little bit less, right? Co-captain, captain, co-captain is less. Okay, co-vertice is 2, 0 and -2, 0. Questions? Yes.
The co-vertex, is it always on the x-axis?
No, it just the distance is a shorter side, so it's not always on x-axis. No, whatever longer side is gonna be
The vertex.
vertice. So longer length. Okay, co-vertice is gonna be the shorter length. Now there's also some other term called major axis. Major axis is the longer axis, and minor is the shorter axis. So this side is called a major axis, and this side is called a minor axis, because major is the longer axis of the ellipse. Now, here's my question. Foci is located on major or minor axis? It's going to be on the major, right? In order for me to draw that ellipse, it has to be on the longer side. If my foci is right here, then it has to be this. So the major axis, the foci, is located at major axis. What else? Well, how do I find the foci? So the foci is always this. Is for me, I write down this equation. It's not mathematically correct, but it's a way that I don't have to think about math. So it's gonna be longer side square minus the shorter side square is equal to the c square. So sort of like Pythagorean identity, but it's subtracted. You have to subtract from long minus short. You don't want to do short minus long because if you square root a negative number, it's end up to be I. So you don't want I, so it will be longer side square minus shorter side square. And they always the opposite from this sign. If this is plus, this is minus. So there's no memorization issue. So your foci is going to be a major axis. It's going to be somewhere roughly right here, but where they at? Well, which side's longer? This 3, right? 3 squared, that's 9, minus 2 squared, that's equal to c squared. So 9 minus 4 is equal to c squared. C squared is equal to square root of 5. Sorry, c is equal to square root of 5. So foci, in this case, is going to be located at a major axis. So major axis is the y-axis. So we should base on the center. Center is what? 0, 0, right? Now I'm going to add a c. So what is c? C stands for the distance from center to foci. So you got to add it to the correct coordinate. In this case, the foci is going to be located at square root of 5. I put it on the y coordinate instead of on the x coordinate. So it'll be 0, negative square root of 5. So that's my foci. Got it? Okay. Now, here it is. I'm just going to twist a little bit. Hopefully you can see what's going on. So what if I have this? Sorry, that's 9 squared. That's the 16. It's equal to 1. Can you draw this ellipse? What do you think this ellipse did? What's the difference between this one and this one? Can you see it?
Transformation.
Transformation, yes, there was a transformation happen. So where's my center? It would be what? 2 comma negative 3, right? Does that make sense? Because I just replaced the x with the x minus 2. But it's inside a parentheses, so therefore that's moving to the right. This one's plus 3, so it's moving down. It's my center. Can I graph this one? Yeah, it's easy. 1, 2, 1, 2, 3. Right here, right? That's my center. I draw a cross. X direction, how far I have to go?
3.
Does that make sense? Ariana, does that make sense? This is below the x. So square root of 9, because this is a squared, so a is going to be a distance to the x direction. So it's going to be 1, 2, 3. So it's going to be right here. 1, 2, 3. It's going to be right here. Does that make sense? How about 16? What does that represent? 4 units, right? So I'm going to go up and down 4 units. So 1, 2, 3, 4. So it's right here. 1, 2, 3, 4. It's going to be right here. So it's going to form your ellipse. Okay. Okay, yes.
The numbers inside the parentheses, those represent where the center is going to be? Like the x minus 2?
Yes.
So
Because the inside parentheses is always opposite.
Okay.
So if I have y squared, that just means 0.
Yeah.
Okay? Same thing before. Are we okay here? So what we're going to do is we're going to complete a square. On this, we're going to show you a general form of the things. We say, hey, can you figure out how to do it? So can you move the camera back? So I'm gonna do it really quick, and hopefully you can catch up. A lot of you guys already learned it, and you guys can deal with harder problem. So 9x squared plus 4y squared minus 18x plus 16y minus 11 is equal to 0. A lot of you guys already know how to do this. A lot of you guys don't, but this is called general form. But here, a lot of you guys even know how to do this. Do you know how to identify this ellipse? So here's a way to identify the ellipse. It has x squared and y squared, both present, and it's adding, because it's adding between x squared and y squared, and then it have a different ratio, 9 and 4, that makes that stretch, okay, stretch in different way. So different ratio, because circle is going to be the same ratio, it'll be 2 and 2 or 1 and 1, okay, different ratio of x squared and y squared. So what I'm going to do is I'm going to complete the square on this one. Now this one's only one small twist. Most of you guys should have no problem, because 9x squared minus 18x plus 4y squared plus 16y, that's equal to 11. Are we okay here? What do I have to do here? Factor what? No, 9. Just the leading coefficient, right? And leave some space here. Plus 4y squared plus 4y. Leave some space here, equal to 11. The only thing different between this and circle is that coefficient in the front. What am I adding here? -2 divided by 2 squared, that's equal to -1 squared, right? That's equal to 1. So I'm adding 1. But am I really adding 1 on this side? Am I really adding 1?
No.
What much am I adding?
9.
9 to the other side, right?
Right.
Now what am I adding on this side? 4? But am I really adding 4? So it's only 16. So therefore it's 9 times x minus 1 squared plus 4 times y plus 2 squared, that's equal to 36. But that's not done yet. Because the ellipse, the other side has to equal to what? 1. So can I divide it by 36 on both sides? So 9 and 36 can cancel out to what? 4, I think.
Yeah.
X minus 1 squared over 4 plus y plus 2 over 9. That's equal to 1. So, voila, that's your ellipse. You're going to try one. And you can find a foci too. And you can learn to practice finding the foci in the correct directions. So here is the question I want you to try. 9x squared plus 16y squared minus 18x plus 64y minus 71 is equal to 0. So you're going to try on this one. Complete the square. Hopefully you can find major axes, vertices, co-vertices, and foci. Foci is always located on the major axis. Okay, try it. Come on. We don't have much time. Take a long field trip. 71. Hopefully it's right. We should take field trip more. We should. Take an all-day field trip. Do math all day. Yeah. I would have taken a field trip. Orlando Science Center is actually not bad. Have you guys been to Science Center?
No.
It's a cool place. I take my son there all the time. But they have a place that you can whisper from the other side to the other side. There's a tube of satellite facing each other. And you can whisper from one side and you can hear on the other side. But that's not as cool as this one. This one's actually really cool. I didn't know how this one worked, which is kind of interesting. But I heard there's a different position too. That you can stand on different places, you can whisper with each other. Not only in that place. That's one of the places that nobody knew about. A lot of band kids knew about it, you know. funny. I like to make fun of you. Maybe remind me of Sheldon. Big Bang Theory. It's okay. He's really smart. He just had great quirky funniness. Can you find the both sides, locations? Those of you guys already learned how to do this. Can you find the vertices, co-vertices, coordinates? Can you find the center coordinates? And the rest of you guys don't have to do that. The rest of you guys just have to know how to complete the square. What's that? You take it this, you take it -1 here. That's a shortcut. And this one is 4 divided by 2. Square that's equal to 4, right? But it's equal to 2 squared first. That's equal to 4. So you just take that.
Also that.
That's a shortcut.
Oh, okay.
It's much faster than actually fact. You can use a box method, but it's will take too long.
No, because I was like, how did it go?
Everybody's finished? And now it's workable, right? It's fine, right?
Yeah.
It's not a bad question.
No.
Let's see.
Remember when you took
No, it's 2 different.
I was sitting on it, but it was really awkward.
Oh, that's what.
But that's what your shirt says, so it's okay. Well, you might not feel awkward, I feel awkward. So I'm only give you one question to complete a square. You can try it. And tomorrow we can try more because we're going to try on hyperbola tomorrow. Hyperbola. She's like, hyperbola? Hyperbola.
No, she's like, I thought that was part of language arts.
Yeah. Hyperbole?
Yeah.
That's different. Hyperbole.
Hyperbola sounds pretty hyperbolic.
Oh my gosh, I
Shut up, man. You sound like Adrian.
Hyperbole.
Gabriel thinks funny. He's like Sheldon, I swear. He's so smart. But he just needed to discover that witness, that comeback. Bazinga.
Lo sé.
You guys get it? Bazinga? Bazinga.
Cogimos y literalmente en la media torta, entonces uno se agarraba en una esquina y otro en la otra. Y